Hey everyone, in this video we're going to talk about bone and ivory, the Paleo-Composite arsenal, and I'm going to talk about a little bit, I'd like to talk a lot about the Paleo-Toolbox, makers of makers, where we're making tools that make other tools. Then those tools make like specialized weapons, etc. Off camera, I've been working on a drill that I needed to make. I'm doing some tests of drilling through bone and ivory. So I'll talk. It's made out of knife river. I took this ball, I think on video. I can't remember. I showed it on video the last time. It was a straight crested flake, and I made this chisel. Oh, I'm going to talk a lot more about this when I get to the tool section, but right now just a glimpse. But this works pretty good so far, and I'll talk more about that too. This is a chisel it's made. It's just got to finish the tip, but made from a flake. And we're going to try to take some flakes today because I ain't done much chipping in these videos, and I want to do some chipping. So we're just going to pretend we need some tools, and we're going to just take flakes. We're just going to do some chipping, Clovis style. So I had this idea that to make a drill, what if you could take a biface that had the thickness and contours like you want, and then you start taking flakes like from the tip, and in a way that's controlled, where you end up with a four-sided instrument, and you could use that as a drill. It already has the taper, which would be the cross section of the biface or the point or whatever. So anyway, I tried it on an old biface. So I don't know if I really think I get enough control, but I had this biface, and I took this flake first, and it's not perfectly triangular. It's small on one end and big on the other. I tried to fix it and take a better one. That was pretty good. Could maybe work with that, but this is heat treated material, and I wouldn't want to use heat treated material when drilling ivory. I'm gonna chip on a couple of rocks. Yeah, got this piece of knife river. I want to make a blade core out of it, like something like maybe, I don't know, some Wenatchee Clovis people, just for example, found the migration route up and over the Continental Divide and down the Missouri River till they got to Knife River country on the high plains. But there's still megafauna around, so, but I don't know, maybe not. But anyway, so I'm going to use this as a transitional core, late paleo maybe, just pretending. I have this platform right here. I'm going to hit it there and knock the end off, and then just continue to take blades. But I don't want cortex where I'm taking blades, and I need a bifacial edge around it. So it's nice whenever you're taking blades for everything to be clean, uniform, crack-free, cortex-free, and you can get more uniform blades, uniform width, uniform thickness. Because I've noticed that I think uniform thickness in a lot of Clovis blade technology is not only evident, but paramount, maybe even. But I'm going to work on this too. This still has a gigantic crack in it from right there all the way to right there. So yeah, I just think of this like any other rock that's got a problem. you knock a flake off and it's still got good material, then maybe you can knock some of that off for a Clovis person. So I don't want it to go to waste. I'd like to knock this flake off, this corner, to start, and I want to make a bigger diameter drill. One that's, like, I don't know, 3/4 of an inch or something, 5/8, I don't know. Anyway, let's see. The problem I have with these videos is I have a lot to say, and so it's difficult to talk about everything that I want to say, and try to remember everything I want to say too, and chip. So I'm going to try to do both, but first I'm going to start out by talking a little bit about bone and ivory. Bone and ivory were very abundant during the Pleistocene era to Wenatchee Clovis people. They used ivory and bone as projectile points. It's in the archaeological record. I'm not just making it up. But let's see. So ivory and the tusks of mammoths and mastodons primarily, and they used the leg bones as well, because the mastodon, 4 tons or maybe up to 8 tons for a Columbian mammoth, I don't remember, but they're very, very large. So the leg bones have to be very dense, and so there's no hollow cavity, and you can use the entire leg bone, where like today on today's animals you can't do that. They all have some pithiness, hollowness to them. Let's see, but stone projectiles for the Wenatchee people was used primarily for small game, and ivory projectile points for large game. We're going to talk a lot about it, but not all of it is going to be in this video. Let's see. I'm going to start off with a con first. I don't want y'all to think I'm just all high, mighty, and glory on just ivory over stone. So I've read a lot about this. A bone projectile point requires 2 times the energy to penetrate as compared to a sharp stone projectile point. Right? Well, if that's true, then why didn't they use stone instead of ivory? I'm going to mention some reasons why. The bending strength of ivory is 2 to 3 times more than flint, higher than flint. So when you go in, you've got a projectile point, stone or ivory. When it goes in to the mammoth, we're talking about mammoths and mastodon, a lot of thick hair and stuff to go through too as well. And stone will hang up more on the hair, and ivory won't. So one unique characteristic that I noticed about all of the well-preserved ivory and even bone artifacts that I've collected, the tip, or all of the ivory projectile point that's showing is super shiny, super smooth, very smooth, and you can see these elongated flat spots all over it, and it's so smooth that it reflects light. I know how they did it. I'm going to show you. It's something so unique. Not that you couldn't do it other ways, but I'm going to show it when we get to that point. Let's see. Ivory has 10 times the ability to absorb shock than stone. So it means that Ivory combines steel-like bending strength with leather-like toughness. It's a must-have to survive bone strikes. You hit bone, it compresses, it bounces off, and stays together. Where stone won't. So let's see. Bending strength. So bending, I know I said this already, but the bending strength of ivory is 2 to 3 times higher than flint, meaning it's a higher resistant to snap on impact. If I didn't say that part, I meant to say that part. I want to talk about the projectile, not just the projectile point, for a minute. The projectile, let's say, okay, so I did some looking up some stuff and a little bit of math. I didn't do the math. I had computers help me do the math. Anyway, a modern javelin. So we're comparing like apples to apples here. You have a modern athlete. It's in very well shape, good shape, the best in the world, throwing javelins to compete, right? And you compare that with a spear in the Clovis age, the Wenatchee Clovis age. Every time I say Clovis, I really mean Wenatchee, to be specific. But so a modern javelin weighs about 1.8 pounds. But let's just round up to 2 pounds. Okay, so let's say, a spear. I did. Let's see. I did some research on that, didn't I? I found what the average weight of some spears were. Aha. Okay. Get to that in a minute, but so if you throw a 2-pound object, all right, thrown by modern athletes, or what Wenatchee Clovis people would be in good shape, just like a modern athlete. So you estimate the maximum velocity that you can throw a 2-pound object, and it's approximately 48 miles per hour. The maximum velocity of a 4-pound object thrown by modern athletes is 34 miles per hour. So the Middle Pleistocene wooden spears from Germany, I don't know how to pronounce them. I don't know how to say it. They weighed about 3.5 to 4.5 pounds. So the Wenatchee Clovis people were also from the Middle Pleistocene era, so that means it's possible that their spears weighed 3.5 to 4.5 pounds, or middle range is 4 pounds, which is twice what a javelin weighs. So you get twice the momentum by throwing a Clovis spear that I'm talking about, and that they're talking about in the Middle Pleistocene era, versus a javelin. I say all that I'm really getting to something later in the future, but if you're throwing a big, heavy spear that requires twice the amount of energy because you're using ivory, then, you have to have advantage. So you need to be upright, up higher, and throw down, and use that momentum to your advantage. I thought there was something else I wanted to say about that. I don't remember, but the Wenatchee Clovis points, as I mentioned before, they weren't projectile points at all. Many people believe it, but go read about it. Like, it says there's no impact fractures. It says there's blood on the projectile points. I'm going to read something from I'm going to paraphrase at least, that Dr. Mike Gramley wrote about them. All the fluted point preforms from the pit feature at the Wenatchee Clovis site bear blood residues along cutting edges, suggesting use as knives or cleavers. The blood residue they tested came from bison, caribou, deer, moose, hares, rabbits, pikas, and even human. It could have been it's not like they meant to cut a human, in my opinion. It's probably an accident, just like us flint knappers do today. And to add to that, the bone rods that were at the site, the bi-beveled bone rods made out of bone, were paired together by size. These two they go together. These two are a little shorter, but they fit and they go together, etc. So they're suggesting that ivory was the projectile tip and Clovis points were not, even though they may not have said it in black and white. I'm going to talk about tools and stuff, like I said, in the next one. Let me pause it for a minute. There's a helicopter. Okay, the helicopter's gone. Sorry about that. This is part of the Paleo-Toolbox. I'm going to talk more in the Paleo-Toolbox. I think is very interesting, and I'm not going to chip this yet until I get through that. I'm going to take flakes from different types of cores, and I'm going to create tools from those, and then I'm going to use those tools to create sophisticated tools and weapon systems. These Wenatchee Clovis people, they were Homo sapiens. They were the same as you and me. There's a lot I learned about them, and people that are way older than them even. They were engineers of sophisticated systems because they were so intelligent, and they had to adapt to a barren, wood-scarce scabland that was prone to flood after flood after flood. Even though wood was scarce, they did find pollen, so suggesting that there's trees large enough to produce pollen. It's not a lot, but there is evidence of pollen. You could find trapped driftwood in scabland cracks, that are still left there after the mega flood. That they need fire, right? So what do they make fire from if they don't have much wood? And man, I know for fires, it just seems like you just keep feeding it and keep feeding it. You have to melt pitch, and you have to boil water and cook food. And so how did they do all of that? Well, mammoth and mastodon dung last a long time. So it'd be like a smoldering, it seems like I tried it a long time ago. I don't remember it making much of a flame, but heat nonetheless. Peat was available and long-lasting as well. They used animal intestines. Yeah, I'm not really sure how that worked with animal intestines either, but there was a reference for it. When you dry it out, I don't know. Anyway, moving on. So, another thing they could do, yeah, you know, they're intelligent, right? So they figure out how to take these basalt stones, heat them in the fire, and then drop those into a bag of water. Maybe the bag is made out of intestine or hide. You could, you can do that. Then you can make hide glue. Hide glue is, you know, a great prehistoric adhesive. You can make hide glues from different parts of the animal, from different animals, so that you have different strengths and different elasticities. you need to cook food, so and there wasn't much wood around, right? But you need more than just hide glue. You need pitch. So one of the, let's see, no wood means no charcoal, or scarce wood means scarce charcoal, but there's other ways. So, and remember too that it's, they, you know, like they may have to travel. Like you can find conifers in I don't know, river corridors. One of the things that were available was Douglas fir. You could collect raw resin from Douglas fir and make pitch out of that. Ponderosa pine was another one. Peat, of course. Pine makes good pitch. Even peat makes good pitch. Another thing they did, they found this. They've mixed ochre and charcoal into raw pitch, and I think the ratio was 3 to 1 to 1, pitch to ochre to charcoal. I think I got that right. That gives the pitch some strength. It helps prevent cracking and brittleness. This is the coolest part, I think, because like I'm really questioning, you know, I ask a lot of questions on like, well, if there's no wood, then how did they make fire, and how did they mix charcoal with it, right? So there's another way. A lot of you on this channel that are watching this video have made charcloth or are familiar with charcloth and how charcloth is made. But the way charcloth is made, a lot of ways people make it. So you take a tin can that's got a lid on it, and like a paint can, a small one, you poke a hole in the lid. You take some 100% cotton and you cut it up into little pieces, little squares, and you put it in the can, and you put the lid on it, and you put that in the fire. It heats up but deprives the fuel from oxygen, so it never really burns it. It makes charcoal, but it's charcloth. That is called, by definition, dry distillation. And you can make ready-made adhesives with the charcoal already mixed in. Like, for example, you could take Douglas fir, pine, and peat and you know, put it in, you know, you're not going to put it in a can, but you starve it of oxygen, heat it up, and you make your the final product consists of tar and the ashes of the bark. So I guess you use the bark. Man, I'm not sure. The bark and the wood, the bark or the wood. Seems like it matters if you're. Seems like it should matter. But anyway, they did this. There's evidence that they did this with birch, and you can also do it with Douglas fir. You can do it with pine, and you can do it with peat. The pitch that they make from this can also be used as a fuel. But it makes me wonder. Well, I'm not gonna say it. So, to me, the takeaway from all of that, and I could go on and on and on about examples, and I'll try to mention them in other videos, but the Wenatchee Clovis people had cognitive skills. As a matter of fact, there's evidence that that people 60 to 70,000 years ago also had cognitive skills on the same level as humans today. I read a study on it. It seems like, was it arrowheads? It seems like they found some arrowheads. So it suggested the use of a bow and arrow. And I think the latest archaeological find of any type of bow and drill, bow and arrow was, I think, about 6,700 years ago, if I remember right. But that doesn't mean that they didn't make these things way before that. So that's what I'm saying, is there's evidence that they could have done it, and they had the cognitive ability to be able to do it as well. So if for this, what I'm talking about, I think this was in South Africa, that means that they had they could use bows of different kinds. They can make friction fires. There's evidence of high-speed concentric holes drilled in things from the Paleolithic era, and I think from around the world too, maybe. But anyhow, so I say all that to say that I'm going to show you some things that are going to be skeptical amongst many people, because they're going to say, well, they didn't find that in the Clovis archaeological record. And I'm just going to say that's because they haven't found it yet. But and they might not ever, but it doesn't mean that they weren't smart and that they didn't use tools to help them. I mean, I'm drilling a hole with my hand, and I'm thinking there's got to be a way I can increase leverage on this, right? So you keep thinking of a way, and then you add a handle to it. Oh, that increases leverage because the radius of the thing you're twisting is bigger. So you get more leverage the bigger the radius. And you can make a long stick and spin it between your hands and make a drill, but you can make a spindle, a wheel and axle, high-speed drill, So anyway, I'm going to get to chipping a little bit, because I know I've talked a lot and I have covered some stuff. So let's see. I'm going to try to make I don't want to mess up my platform, but I want to try to create an edge all the way around this and get with it. They say, Neanderthal, they say, oh, you've, they take a rock and you hit it, and then you flip it over and you hit it, and you flip it over and you hit it, and you flip it over and you hit it. It's a very strict culture. So it's easy to teach others how to chip, how to make a hand axe that they call a hand axe, which is just a knife because of the way it's made and how it gets used up. So anyway, it's my opinion, but that part doesn't really matter. The part I'm trying to say is Neanderthal were smart people too. They made tool flakes off of prismatic cores, just like the Clovis people, just like the I forget, the people in Europe. It was a technology that they used all around the world. And I believe there's something very special and unique about prismatic blade technology that allows you to take uniform thickness or within some degree of variance that's allowable, and the same with width. Sometimes you're looking for triangular flakes with ridges, with one single ridge, and sometimes you want two ridges so that there's a flat spot. they were smart. I guess we just don't give them credit because they're not around anymore, but we don't know why they're not around anymore. They just know they disappeared and they don't know why. So you make these cores. Everything needs to be uniform and clean. I don't know if that hammerstone is going to work for that. Just trying to get in there with enough mass. It's too big too. Come up in this way. Anyway, when you're making these, you don't really want to lose all your thickness either. So they were very short blending blades unless you had to clear a bunch of crap off. I think I'm just going to take some example flakes from this, but those Neanderthals, they made tools from those flakes. They were pretty cool. It seemed like really surprising me. It's hard to get in this spot. I don't want to keep messing with it. I just want to hack through it. It's not the right way. I'm limited because it's small rock too. And what I can get from as Clovis tools. I still have a lot of chipping to do in these videos. And some more talking, but not as much talking. I'm going to talk about flake science. Probably on the next video. Let's see. That's got to be clean on this side too, or else I can't take flakes from it. So I got to hit this here. Take a big wide flake that doesn't impede on this platform. If it does, it's I don't know, it might change the whole plan. And it's got to be in the right direction, because once I take a flake here, the platform's going to move up and up and up. So I need to make sure that I've got a place to hit. So that's what I'm doing. And I'm going to call that good enough for that, but I'm going to true up the edge just a little bit. Flakes travel better that way. I'm going to true this up as well. I'm going to get a smaller hammerstone for that. Use this. Let's see. Right there. Okay. That flake is gone. Get that, move that out of the way. For my first primary flake. There's for any type of core, but we're talking about Clovis cores here. We're talking about Wenatchee cores too, but Clovis cores, or just cores in general, they're kind of the same. except for maybe the tool that you strike it with. Might not be. Okay. Dun, dun, dun. I'm going to talk about flakes, or when I make the flakes or get to that part, I'm going to talk about flakes that can be used for like a draw knife, a scraper, cabinet scraper if you're into woodworking, chisels, wood drill bits that could also drill through ivory, core and platform preparation. Like, I want to iterate, and especially once you really see me make these tools and you try for yourself, you're going to understand for yourself that this takes some serious skill. When you're making these tools, they're very precise, they're very precision, small controlled flakes. And oh, there it is. I forgot what I was saying. Required this, what I was saying was this requires some skill to make these tools. Now, did they make crude adzes? They look crude, but they were, the function was the same. Maybe they didn't haft as cleanly as, you know, a napper that had more skill. So it doesn't mean that you have to have a lot of skill to do this. Go do this. This is fun. That looks too thin. Gotta thicken it up. You imagine what tool you need, and you gotta make that from the flint you have without wasting a bunch. So then you see the flake, and you can see the tool in the flake. So you set it all up with that intent, hit it with that intent, and then you go make the tool out of that. I don't really understand fully the concept of, or the need, I should maybe say, of crested flakes. Like, you need to take crested flakes. I'm setting up one now. You need to take crested flakes to get into the course, and then the crested flake is the first flake taken that allows additional flakes taken from that. But what is the crested blade used for? Anything? I mean, I wish I really knew. Like, I made some straight ones, obviously, and made that drill. But, what about the curved ones? Did they do anything with those? That's not waste, surely, right? That's have something to do with it. I know there's straight sections in there, but let's see. I think I'm just gonna extrude up the edge to there, and it's not a real pretty thickness. It's got a little cortex on it still, but I can get that off later, hopefully. But I'll take a few flakes right there. That is close to being set up. probably needs to come trim the tip a little bit more. Not the best of platforms because that big, or it won't be the best of flakes, I mean, because of this sticking out right there. I didn't realize it was going to leave that much in the beginning, but it should be ready. Man, I don't like part of it. I can already tell I'm going to switch over to the Burlington one. This isn't going to be good setup for the best striking platforms. I have to do more work to it to do that. But I'll try to take that crested blade there. There. Crested blade. Well, that's got to have a good use. There's the remnant scar, so we can continue to take flakes from there and there. For Clovis, each flake requires setup. It's not like a Dalton flake on my Dalton videos, where you try to do as little of this preparation as possible. Clovis is more precise. The Clovis, like let's say Wenatchee, if you believe in the theory that they came from the northwest and went, south from there or whatever, then once they got to Missouri chert formations, that's it. I mean, the Clovis show was over. Like you've got all the must be the largest, I don't know, I shouldn't say that, but it seems like it could potentially be the largest single resource of chert in the U.S. Texas is another one, but there's a lot of, so when they get to, they just become Dalton people. It ain't as much work. You don't have to travel as far to get your rock that you're going to carry. And they did a lot of this at quarry sites. There's evidence of it. The quarry site for Wenatchee is, I can't remember, 250 miles to the southeast, I believe. So that's a long ways to carry that yellow agate. But that yellow agate was, there was a lot of quarrying that went on at that site. And it made me wonder, was it just the Wenatchee Clovis people? Surely. Alright. I can't hit that very well. None of these are really exactly favorable, but make it work and get one or two flakes here before I move on. There, right off the corner. There's the platform. I had to hit it in the exact right spot because it's a wonky place for a platform. And then I was going to hit it right here at this corner, but we'll see if I'll be able to do that. Maybe. think I can get it though. It's another one of those weird ones. Like the platform is there, but you gotta hit it right. Not real hard. You see it? Right there. I've been making tools the last few days, and it is sure taking me some time to recover. I still don't have hardly any grip in this hand. Okay, if that doesn't crush right there, then I got it. It's one of those real small places. You may not hit it on the first try, but you keep adjusting your aim and you get it. Okay, right there. There. And see, there's one. It's got a flat spot on it. So, it's nothing to do here. You work this edge up to your flat spot to create the tool or whatever you want. But anyway, there's, I love that flake. And there's the resultant core. Pretty much scoured and took off the other flake that was over here, I guess. But there's more. I could take off another one right there and just keep going. There's a spot to hit right there. There's not much to it. And just keep going and make these for something. That's probably all I'm gonna do to that rock on this video. Now I'm gonna hit this rock. I know I'm already long into this video. I said I wanted to take this and try to make a bigger drill out of it. And there's a crack from there, goes all the way around to there. But besides that crack, and this little dab of Cortex here, it's pretty good. It's really good. There's a seam of color and there's some rough pockets in that color. Okay. So one thing I want to show, a little class, I don't know, teaching demonstration I'm trying to point out. You can clearly see this ridge, and there's nothing I'm going to do to that ridge. It's there, it's set, it's in place. Now, it's going to curve when you take it, so a couple things. One, you know, we want to clear this. We don't want to take off this. It's not going to be part of our drill, so it'd be nice if it came off. To there would be the worst case scenario for me, or worst case goal. But the top is what I want to talk about. The striking platform, the striking surface, even though this is great, it's flat, it's a great place to hit, it's not perpendicular to that ridge. So for Dalton, maybe we could get away with it. We can hit right there on that face in the direction of that ridge. But for Clovis, I'm not going to do that. So take flakes back here till we get it right. Okay, that was kind of a primary isolation flake, and it doesn't mean this is perfect. There's some more work to do right here, but that was the primary flake. It's more small percussion work, too much to push off with the sandstone. It's an important flake right there. Get some more. There. Okay. How many flakes can I get before it fails? At the crack. When you're looking at it like I am, instead of pushing it off, I'm pulling them off. You can see it, you know, what needs to come off and what needs more, what needs less, etc. Wish I could get that off, but I'm afraid that'll ruin my platform if I try too hard. I think I've seen on some videos somewhere where you grind, some people will grind this ridge before they take the flake, but they could have used that. They can use that edge. I'm going to show. I want it left sharp. Let's see. Okay. Without any grinding, you can see there's the flake I want, and you can see my platform is perpendicular with that. Yeah, and there's a knob, look at just a nub sticking out right there. It's reliefed there and reliefed back here. There's one little ridge right where I want to hit that could potentially be a problem, but I'll braid it out and hopefully it'll be fine. I mean, the Clovis people were just masters of their craft, and whenever they moved into Burlington country, Cobden country, you know, I mean, they just felt right at home. Big chunks of Burlington, Kalen, right, too, but Cobden, man, that was fun for them, I'm sure. I think a lot of Cumberlands might have come from that. I think that's gonna work. All right. That's enough. Yeah. Okay, I'm gonna hold it. My paleo glove. And I'm also going to put this underneath there too to help with shock. And that on top of it. Alright. This should be a no-brainer. There. Okay. So, put it back on there and show you the result. Strike. I said, worst case goal, I guess, for me would be literally to come off right exactly where it's at. I didn't want it to come off any more. So now we have a great flake, and it's thick. I can make, I don't know, a thick drill or a thick chisel or something from this, a gouge, I don't know, but I'm going to save that. That's an excellent Clovis tool flake. Okay. The next place to hit right here literally is right on that crack. Hit this. Let's see what happens. I want to take more than one flake before I stop this video. Come on, come on. It's in the crack. So that means, I have an idea. Do this right, it won't obliterate my platform. It didn't really, oh, there's still more. Oh, there's a couple of small cracks there. Isolated. Okay. This should go to that crack if I can get in it. Okay. Need a little bit more. Okay. So this is pretty cool. I'll show you this. I'm setting up to strike there. It's really just messed up, and I don't know if I'm going to get the flake because the crack runs right along it, but as long as I get my initiation and the crack doesn't interrupt the initiation, then it should be okay. However, this is the cool part. you look along, if I take, so I'm thinking of taking this, right, or this flat section here, but this, it goes up. Can you see that? Am I showing it? So it doesn't follow the natural curve of a flake. In this case, I honestly don't think it's going to matter, but I wanted to show it because there's a cool way to fix it. So just like on my other core, there's something similar, and there's a cool way to fix it. But this corner right here, if you take a platform, create something to hit right there and go in that direction, you can end up with a nice tool flake with a ridge on it and get rid of the mass that's right here. And this flake will follow and travel easier. Okay. Alright. I don't think. Yeah. This crack is definitely going to mess things up. Yep. We're going to give it a try anyway. Because I don't mind failing on film. They failed in person too. I mean, they failed in real life too. They didn't get everything. Besides, I'm really leaning on this crack causing a problem. Not help, I don't know if I'll be able to work around it on this flake. We're gonna hit it like it's not there though. I think that's the best way to do it. You hit it like you don't see color. Never matters. The only thing that matters is the flake. Yeah. Got it. Now I just need to give it a grind. Can't quite see it. See it now. There it is. More of a ridge there than I want. Okay. This one, that'll hold together. Can you hear that crack? Yeah. Well, here we go. There's a nice pointy end on there now, so I'm going to put 3 layers here. Yep, might break. Sure sounds funny. got it. Alright. There's the platform I hit right around all the cracky crap. And yes, that's a beautiful flake. That'll make an excellent tool. It's nice and flat for a long ways. Wow, okay. I love it. Now, I'm really long on this video, so I'm going to stop right there. But I must show one thing. See this hump? We went through it, but there's a hump still there. This has to come out now to get any further reduction along this ridge. Alright, thanks for watching.